Hello everyone. I, Nilima Varade, working as an assistant professor in the Department of Electronics and Telecommunication Engineering from All India Sri Shivaji Memorial Society's Institute of Information Technology Pune. Today, I will be discussing on TTL NAND gate. Introduction to TTL NAND gate. The figure in the PPT shows TTL NAND gate with a totem pole output. The totem pole form is as shown by dotted lines in this figure, which means the addition of an active pull-up circuit in the circuit in the output of the gate, which results in the reduction of propagation delay. Logic operation is the same as the open collector output. The use of transistors T4 and diode is to provide quick charging and discharging of parasitic capacitance across T3. Also, it provides low output impedance. The low output impedance means a short time constant RC. Therefore, the output can change rapidly from one state to the other. T1 is multiple type emitter transistor. The transistor T2 functions as a phase splitter. Since the emitter voltage is out of phase along with the collector voltage, the transistor T3 and T4 by totem pole output and CL shows the stray capacitance. Operation of the TTL NAND gate. When input A, B and C are high, base emitter junction of T1 are reverse bias. So, no current flows to the emitters of T1, whereas the collector base junction of T1 is forward bias. So, the current flows through R1 to the base of T2 and T2 turns on. Current from T2 emitter flows into the base of T3. Therefore, T3 turn on. The collector current of transistor T2 flows through R2 and so produces a drop across it, thereby reducing the voltage at the collector of T2. Therefore, T4 is off. Since T3 is on, V0 is the output at its low level, that is VC is sat, and therefore the output is at logic 0 as shown here. Right? Then when either of the input or all inputs are low, the corresponding base emitter junctions are forward bias and collector base junction of transistor T1 is reverse bias. The current flows to ground through the emitter of T1. Therefore, the base of T1 is at 0.7 volts, which cannot be forward bias. The base emitter junction of T2. So, T2 is turned off. With T2 off, T3 does not get the required base drive. Therefore, T2 is also turned off. Transistor T4 gets enough base drive because T2 is off. That is, no current flows into the collector of T2. All current flows into the base of T4. That means T4 is on and the voltage, that is the output voltage is at logic high. So the circuit acts as a multiple input NAND gate. This is all for today's video. Thank you everyone.